Okie dokie. Great problem. Here in this problem, they provide us with the differential equation y prime equals t squared on a certain grid. And they're basically just asking us to identify what the slope field is that corresponds to that differential equation. So the first thing we want to do is probably just pick a single location that we can use to help us start narrowing down our options. So what do I mean by that? So here, 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 and here. In that same spot, let's go ahead and figure out that ordered pair. It's t equals 1 and y equals 1. So in 1, 1, we have two positive slopes, a and b, and two negative slopes in c and d. So what can we do? Let's plug in this ordered pair into y prime and see what the output is. So if we plug in t squared, or plug in our t value to t squared, that would be 1. And we get a y prime value of positive 1. So right away, it's telling us that any time the t value is 1, the y prime, the slope value, should also be a positive 1. So that means we can eliminate any that have negatives at t equals 1. All right, so then let's pick another location that would help us distinguish between options A and B. So something I look at is this center point here. So that is at t equals 1 and y equals 0. So again, we're going to plug in this ordered pair into the differential equation y prime, but you'll notice each time there's no place to plug in a y value. So really every single time the y prime value is dependent on just t. And so in this case we're just plugging in t equals 1 again. So we get a y prime value, or a slope value, of 1. So just like that, we know the slope value can't be 0, can't be flat, so it can't be a. So what we found out basically is excuse me, because the y prime value is only dependent on the t value, we can see as t starts at 0, all these are flat. And as t goes to 1, all of these have a slope of 1. And then as it goes to 2, all of these have a slope of actually what would be 4, because you're squaring 2 once you plug it in. So that's basically the idea. So process of elimination, and then just making sense of it with the differential equation for all other t and or y values. So let's break out the eraser to see that B is in fact our answer. Let's go ahead and do the second example. All right. So in this one, a little more complicated. We have y minus 2t. So in this case, t and y will play into it. But let's use the same elimination method and see how that goes. So let's pick a point where we can distinguish the value. So I'm going to pick this middle value because it looks like 2 slope fields have positive slopes in that location and 2 have negative. So where's that location? Again, it's t equals 1, but y equals 0. So when we plug these in to the y prime equation at the top, we have y minus 2t, so 0 minus 2 times 1. As a result, we get negative 2 for our slope, or for y prime. So any values that, or any slope fields that have a positive slope at that location can be eliminated. So just like that, we narrowed it down to just B and D. So let's look at B and D and see where we can find a difference. So we can either go with, we have a couple of different options. Let's go ahead and just do this point and this point. So what is that ordered pair? That should be t equals 1 again, but y equals 1 this time. So we're plugging in 1 and 1 into y prime. So we have y minus 2t, so 1 minus 2 times 1. That'll give us a y prime, or a slope value, of negative 1. So between B and D, which of those circled segments has a slope of negative 1? That would be option D, because B has a very positive slope at that point. So break out the eraser to see that D is in fact our answer. So I really like this elimination method. I think it's a good direct approach to it, because otherwise there's so much to look at in these slope fields, but the elimination method is a way to really break it down. So I hope this helps. If you have any questions, please let me know.